GJ Math.
Now we will look at exponential equations. So if you've been following along in this playlist for exponents in grade 11, everything we've learned up till now, we're going to apply, but now it is equations. So in the previous ones, we didn't really get an answer as x is this or x is no solution or something like that. We only got expressions as answers. Now we are going to get x equals to something. So you're actually going to solve by using all the rules that you know already. So the three types we've discussed previously, or type 1, and then the two sections for type 2, are going to be present, but equations. Let's start. Type 1 you get when you have one term equals one term, or you can move things around until you have one term on each side of the equal sign. What you're going to do is you want to prime base both sides until you have one base on the left and a similar base on the right, so that you can drop the bases and equal the exponents. Let me show you what that means. So in this case, I see a 4 and a 16, and I know the base for both of them is a 2. If you are uncertain, please use the shift fact function on the calculator, and you will see exactly what I mean. So in this case, I am going to rewrite the 4 as 2 squared, but the exponent that was there, I must just keep there. And then 16 is 2 to the power 4, and the y is still there. So now I can multiply in with the exponents. So 6y plus 4 would equal 2 to the power 4y. So now my bases are the same on both sides. I can drop the bases and say the exponents are equal. So 6y plus 4 equals 4y. I move the y's to the left and I have 6 minus 4, so I have 2y equals 4, and therefore y equals 2. Okay, so that I do if I have one base on the left or the right. Now type 2 is when I have multiple terms and there are more than two terms. So I can't just have one on the left and one on the right. So let's see what would happen then. In this case, I will then give each exponent its own base in order to take out a common factor. Let's see what that means. So I can keep this first one just like it is. But in the next one, I'm going to say it's 5 to the power x times 5 to the power 1. Still equals 40. Now I can take out a common factor of 5 to the power x. Let's see how that looks. So 5 to the power x is going to be 3 plus 5 that remains equals 40. I can see that bracket is an 8. So 5 to the power x equals 40 divided by 8. So 5 to the power x equals 5 to the power 1. And therefore, bases are the same. I can drop them, and x equals 1.
This is an example of a type 3, or previously I called it type 2, but the advanced version. So what's the difference between this and the one we've just done? You will see there's a 3 to the power x and a 9 to the power x. But if I break down the 9, I can say the 9 is 3 squared. So the one exponent is double the other one. And then I know I'm going to have to do K method in order to do a trinomial or difference of squares. So let me show you what that means. Firstly, the 9 I'm going to rewrite as 3 to the power 2x minus 4 times 3x. Just like the previous sum, because there are pluses or minuses, I'm going to give each exponent its own base. So that little plus 1, I'm going to make 3 to the power 1 plus 27. Now, don't worry about the 27 because it doesn't have an x. I don't need to prime factorize this. I know it's 3 cubed, but it's not going to help me in this sum. Okay, so now I want to make something k. There is my smallest exponent, and there is one that is double that exponent. So that is going to be my k value. So let k equals 3 to the power x, and then therefore k squared would equal 3 to the power 2x. So if I rewrite this, it's going to be k squared minus, there's a 3 and a 4, so that will be 12k plus 27 equals 0. Now trinomials. Okay, two brackets. I know this must just be k and k. I need to look at the factors of 27. So that is going to be 3 times 9. I'm going to say the 9 there, the 3 there. How do I know it's minuses? My trinomial started with a minus and ended with a plus. So the terms are, the brackets have the same sign. Both sides must be a minus. Now I can just equal both brackets equal to 0. So I can say k minus 9 equals 0, or k minus 3 equals 0. The question was not to solve for k, the question was to solve for x. So now I need to replace my k value back with what it was originally, 3 to the power x. So I can say 3 to the power x is going to equal 9. 3 to the power x is going to equal 3 to the power 1. So in this case, I just want to make the bases the same, and therefore x equals to 2. In this one, bases are already the same, so I can drop them and say x equals to 1. Okay, so very important that you see there was an x and a 2x in the sum. That's why it's so much more complicated than the previous one we did. I have to go K method in this. Here are two more examples. So now, it does not say which one is type 2 and type 3, because in an exam it's not going to tell you, and it's going to try to confuse you. So let's just look closely at these sums, because they are a bit more technical. So in this case, I can see there's a 3 to the power 2x and a 9x. So it looks like the one is double the other one, but the bases are not the same. So my first step will be to break down this 9 into 3 to the power 2x minus 3 to the power 2x, and that 1 I'm going to give its own base. Okay, now I can see this is actually a common factor sum, because now the exponents are not double. It's actually similar. So I can just take out 3 to the power 2x. I'm going to be left with 3 minus 3 to the power minus 1 equals 24. Okay, so you can now type this just on the calculator, say 24 divided by that bracket, or we can do a bit of mental math. So if I do the LCD in this case, I can say this is 9 over 3 minus, remember, if you have a negative exponent, it makes it a fraction, minus 1 over 3 equals 24. And then I can just say, okay, but 3 to the power 2x equals 24 divided by that answer, and I can see that is 8 over 3. So 3 to the power 2x equals, just type that in your calculator and you'll see it's 9. 3 to the power 2x equals 3 squared, therefore 2x equals 2. And finally, we can say x is equal to 1. So watch out. Don't decide before the time that this is going to be a trinomial because I see a 2x. Simplify the sum as far as you can and then see what type of sum this is. The one exponent was not double the other one, and therefore I could take out a common factor. Let's look at the next one. So now I have a 4 to the power x and a 4 to the power minus x. There's nothing that's double the other one. So my brain tells me this is a common factor sum. But be very, very careful. Because of that minus, it changes everything. So let me rewrite this sum. 4 to the power x minus 32. Remember, a negative exponent brings the base down. So I can put it over 4x plus 4 equals 0. So now this looks like a trinomial, but again, there's nothing double the other one. But now I'm stuck with something at the bottom. I am first going to go K method. And when you see a variable at the bottom like this, please go K method. So I'm going to say let 4 to the power x equal k. That will now help me to see this is k minus 32 over k plus 4 equals 0. If I multiply each term with k, that's where I get my trinomial. Just going to swap the following two terms and say that's plus 4k minus 32 equals 0. And now I can solve, because I can say, okay, so it's two brackets with a k. I need to take the factors of 32. When I minus them, I must get 4. So I know it's 2 times 16. That's not going to help. But 4 times 8 is going to work for me. So I'm going to say 8 there, 4 there. This is plus, this is minus, equal to 0. And therefore, k equals minus 8, or k equals 4. I'm not trying to solve for k, so I must replace my k value with 4 to the power x again. 4 to the power x equals minus 2, or 4 to the power x equals 4. Now, big red lights need to go off. If my base is positive and the answer is negative, then it is a no solution. No solution. There is no exponent in the world that can change a 4
into a minus 8. And if there is one, you're not going to learn about it at school. So just write no solution if you see that case. The other one, bases are the same, so therefore x equals 1. Okay, guys, I hope this made sense. Now you can see how we actually apply the rules and the laws and the types of exponent sums to get an answer with equations.
If this video helped you, please like and subscribe.
JJ Math!